Hello students, and welcome to topic 12 of alternative and renewable energy sources. The topic we will be covering is how to design a wind turbine with RETScreen. We are first asked to calculate the wind power density of the 5 wind speeds representing the annual wind at an area. We first cube each speed, add all the cube speeds together, and then take the average. We then can use that average to calculate the wind power density. The average of the cubes is 112 meters cubed per second cubed. This value multiplied by 1/2 and the density of air gives us the wind power density equal to 68.6 watts. It is very important to note that we take the average of the cubes of the wind speed, not the cube of the average, which will give us a smaller answer. We are to design a wind turbine to meet the standalone electrical needs of a home with the electrical uses given in the table. The system is to be a 48-volt system, to have 3 days of autonomy, and have a battery discharge limit of 70%. Open RETScreen 4. Click to see the product database. Scroll to Power, Wind Power, 1 kW off-grid. Click on the green check mark to return. To select the weather data of a location, click on Select Climate Data Location. To select the weather data for a location, click on Select Climate Database. Select the United States in the first drop-down, Ohio in the second drop-down, and Dayton in the third drop-down. Then click on the check mark. Click on the energy model. In the second drop-down box, select Natural Gas MMBTU. Enter 6.5 for the cost per MMBTU. Enter 61 for the kilowatt hours per day, the highest used month. Click on the percent of the month used. This will allow us to enter the electric usage by the month. In each month, divide the kilowatt hours for that month by the 61 to obtain the percentage for each month. Enter 10 for the kilowatt of the system. Enter 90 for the percentage of the efficiency of the inverter, and 3 for the percent miscellaneous losses. Enter 3 for the days of autonomy, 48 for the system voltage, 90 for the battery efficiency, 70 for the percentage discharge, 95 for the efficiency of the charge controller, ambient for the temperature, and all the wind speeds in the left column need to be changed to match the wind speeds in the right column. Change the measured height to 10 for 10 meters and change the shear coefficient to 0.14. Then click the See Product Database. Select Berkey, then at 36.6 meters, number of units 1, then click on the check mark. This selection only supplies 73.5% of the electricity. Click on the See Product Database again and select another wind turbine. This time select DWind, 60 to 70 meters, and number of units of 1. Click on the check mark again. This wind turbine supplies 114.5% of the electricity. This is a good design solution. If there were any questions, please post them on the eLearned Help discussion.